Hi all, this is Shweta Reddy, working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. Today in this video of wireless communication, we are going to see about types of MIMO. Before seeing the types of MIMO, we are going to recap what is MIMO. So, as I said earlier, in this video, we are going to see about MIMO. MIMO stands for multiple input, multiple output. In order to improve the radio link performance, instead of using single antenna at the transmitter side and at the receiver side, we can do the replication of the single antenna by more than one antennas. That is the concept behind this MIMO. So MIMO, it is the meaning of multiple input where we can connect more than one antenna in the place of single antenna at the transmitter. That is the meaning of MI, that is multiple input, and multiple output means here the transmitter antenna will give different versions, that is number of versions of the same input which is transmitted by the transmitter. That is the meaning for MIMO. So MIMO is a technology that is used for multiple antennas in transmitter side as well as in the receiver side. So this is a simple representation of MIMO where we have connected multiple antennas at the transmitter side and multiple antennas at the receiver side. So this multiple versions of this antenna in both transmitter and receiver will be supporting the wireless communication for its multipath propagation. So let us see about types of MIMO. There are four different techniques in wireless communication in order to use antennas at the transmitter and at the receiver. So before this MIMO concept came into picture, we have we had three more things, that is SISO, single input, single output, SIMO, single input, multiple output, and MISO, multiple input, single output. So these are the three versions related to MIMO. So first one is SISO. We will see what is SISO. So coming to single input, single output, where we have a single antenna connected at the transmitter and single receiver antenna also connected to the receiver. So whatever the signal transmitted by the transmitter, the single version has to be transmitted by the single antenna, and it is captured by single receiver antenna, and it is given to the receiver for its propagation. So if you want to improve the efficiency or the radio link performance of this single pair of antenna, we have to replace this single antenna by multiple antennas at both the transmitter side as well as at the receiver side. So what will happen if transmitter and receiver employs multiple antenna? We will see this while studying multiple input, multiple output. I'll answer this question while we are seeing about multiple input and multiple output. So now we are going to see the second one, which is MISO, multiple input, multiple output. Already we have seen SISO, right? That is single input, single output. This is the second one, MISO, which is nothing but multiple input and single output. So here multiple or single, we have to decide based on the number of antennas which is used in the transmitter and receiver. So if it is multiple input, single output means here in the transmitter side we have to connect multiple number of antennas, but at the receiver side we have to connect only one antenna. That means the multiple version of the transmitted signal, that is multiple antennas in the transmitter, takes multipath to propagate, and all the multipath signals will be collectively captured by the single antenna at the receiver side. So this is the meaning for MISO. It can also be called as transmitter diversity. So the third one is SIMO. So we have seen two things. First one is SISO, that is single input, single output, and the next one is MISO, that is multiple input, single output. Now the third one is SIMO, that is single input, multiple output. That means we have to place the single antenna at the transmitter side, and many number of antennas have to be increased at the receiver side. So whatever the signal transmitted by the single antenna, it takes multipath to propagate in a free space, and all the multipath components has been received by the number of antennas which is connected with the receiver. So this is what single input, multiple output. Since we have replicated the single version by having multiple antennas at the receiver, so This is called as receiver diversity. You can observe that in MISO, that is multiple input single output, we have multiple antennas at the transmitter side. So it is called as transmitter diversity. So wherever we have multiplication, that is that will provide diversity. So since in MISO diagram, that is the second type, the transmitter antenna is in multiple numbers. So that is the reason why we call SIMO as transmitter diversity. Whereas here in this figure, can you see that is in SIMO, that is single input, multiple output. The receiver antenna has multiple components. That is the reason why we call SIMO as receiver diversity. So here out of these two signals, the receiver will process the strongest one. So in this diagram, we have represented two different paths. That is here the receiver is reaching two versions of the same signal, that is transmitted by the transmitter. So it will decide which signal is the best one. That highest quality signal will be taken for its processing. So this is what called as SIMO. So while seeing single input, single output, I have asked one question, that what will happen if transmitter and receiver employs multiple antennas? So this is the answer for that question. That is the usage of multiple input, multiple output MIMO have replaced single antenna by many number of antennas, which is represented by NT here. So NT is the total number of antennas at the transmitter, that is N is the total number and T is the transmitter antenna representation. So N number of total antennas is used at the transmitter side, and whatever the number of signals, that much amount of multipath has been taken by the transmitter signal by the transmitter. So all the signals will be captured by the wireless channel, and then it will be released to the another opposite direction, which will be captured by again the n number of receiver antennas, which is represented by NR. So NR represents the total number of receiver antennas. So whatever the number of signal that is captured by the NR antenna, it will take multipath, that is n amount of multipath direction to propagate, and it will be captured by the receiver for its propagation. So in this MIMO, that is MIMO system, totally we have NT into NR number of antennas, where NT is the number of transmitter antennas at the transmitter side and NR is the number of antennas at the receiver side. So in this video, we have seen what is MIMO, that is multiple input, multiple output. And also we have seen the types of MIMO, that is what are the types we had before MIMO came into existence. So thank you all.